Hello, everyone. Today, we are going to talk about sentiment analysis and opinion mining. Sentiment analysis has been traditionally done using rule-based natural language processing techniques. However, we are going to explain some of the approaches we have taken using deep learning here. Digital currencies are on the news these days, as many of you would know. And people who are involved actively share their opinion in social media. So we chose digital currency forecasting as a proof of concept to demonstrate here time series modeling and sentiment analysis, but it can be generalized into any use case of opinion mining. So let's get started. I'm Joyesh. I'm a senior engineer at Intel. I've been working on Hadoop and Spark ecosystem for the last 5 years, working on some of the reference architectures in financial and healthcare verticals. And showcasing performance improvements in software and hardware stack using Intel architecture, memory and storage solutions. And this is my colleague Shibani.
Hi, I'm Shibani. I work as a software engineer at Intel, where I work on designing and developing reference architecture solutions for Intel architecture. And they are specifically focused on machine learning and deep learning.
So the agenda for this talk today is we're going to walk you through the current trends. Then we're going to showcase, Shibani is going to walk you through the data science workflow overview. We're going to discuss the execution and implementation model. We're going to discuss some of the model evaluation and learnings we obtained from these experiments. Discuss some of the further research happening in this field in sentiment analysis and LSTMs in general, if you have not figured out yet, and the key takeaways. So let's set the stage first for what this talk is about and what this talk is not about, most importantly. We are not going to turn you into overnight millionaires, and we are not going to teaching you how to pick stocks or time the market or making any predictions here. What we are trying to showcase is how easy, the ease of time series modeling and natural language processing using deep learning. We would presume hedge fund and currency traders using a lot of different and more advanced data sources and have access to more data sources than what we demonstrate here. What we want you to focus on is how to envision and operationalize some of the algorithms and some of the pipelines involved here, and how to implement this proof of concept using modern distributed frameworks like Spark and TensorFlow. So first, the current trends. So sentiment analysis is actually a pretty complex field of study. It's actually not just a social media tool. It has been studied for a long period of time. What we see is the discussion forums provide a whole lot of general perspective on opinions than static documents or articles or blogs. Social media data is also pretty interactive and temporal. And sentiment analysis essentially is important as it tries to build, protect, and expand brands into new territories. And if you're not paying attention to the same, it can also lead to demise of your products or businesses. Next, what we observe is the maturity of large-scale machine learning and deep learning frameworks. So many of you must be aware that almost from all of the top AI organizations, we have some very mature frameworks like TensorFlow, CNTK, MXNet, BigDL, Theano, Caffe, Neon, etc. We also see that folks are using high-level Python-based neural networks API like Keras, and it's mostly popular among data scientists who are moving to deep learning. And it's pretty neat because it leads you to spend less time dealing with a tool, and once you have an idea, you can quickly convert it to actual research. Keras can switch between multiple backends, so you can delegate the performance optimization to the backend it's running on, like TensorFlow or CNTK or Theano. And it also has sequential and functional APIs, which you can implement, which you can use to implement, let's say, multi-output models or acyclic graphs, or etc. I definitely recommend you folks to go ahead and check out the video question answer model implemented in Keras, where they concatenate NLP-based model, which is essentially embedding LSTM, with vision-based image model in just 20 lines of code. So that's pretty powerful and pretty neat for data scientists, essentially. Next, Sorry. So the state of AI in sentiment analysis revolves around today as embeddings, bidirectional RNNs, bidirectional RNNs, and LSTMs. Most of the talks, if you have attended, have spoken on some of that in the Spark Summit, and some of that we will present as well next. The field also has been subcategorized into sentence level, document level, and aspect level. We'll touch upon that a little bit in further research. And we also see a lot of cross-lingual, multilingual, multimodal data sources being available. So scientists are looking at how do we capture those data sources and how do we create models around that so that we can do sentiment analysis on textual, acoustic related data. So with that, I'll pass it on to Shibani to explain the data science.
Yeah, so for data, we have two kinds of data. One of them is price data and the other is textual data. So for text data, we refer to two sources. One is Reddit and one is Twitter. So on the right side, we see a diagram where, I'll just get a pointer. So like, there are certain channels in Reddit that are specific to finance. So people talk a lot about finance there. They comment, they post articles, and we refer to a Reddit dataset where we filter it out for these specific channels. And we'll elaborate on why we do it later in the slides. And for Twitter, we have a certain set of hashtags that, like, some of them are like happening topics right now, and then there are some that are mentioned very often, and there are some that are outdated. So we select some of the hashtags from the most often mentioned ones. Yep. Next. Now we'll talk about natural language processing. So natural language processing is a technique that programs computers to analyze and process language data. Some of the applications of natural language processing are understanding language, speech recognition, and language generation, and sentiment analysis. For sentiment analysis, we focus on two techniques. So like, there are multiple ways to do it, including machine learning, deep learning, and traditional conventional methods, which are rule-based and statistical. So we focus on two of these. One is statistical and rule-based, and the other is using deep learning. So for deep learning, we have like three mostly used neural networks. We have RNNs, which are recurrent neural networks. So these, they use the previous output at each node. So they combine the previous output of that node with the current input. And then we have LSTMs, which are long short-term memory. So long short-term memory, as the name suggests, takes a longer context of the previous inputs into consideration when evaluating the output for the current node. And then we have GRUs, which are gated recurrent units. These are also, again, better at estimating long-term dependencies, and they work efficiently over small data sets. So now we'll go through the workflow. So our workflow consists of like data set, and then there's some ingest and wrangling on the data set. So we have like two sources here. One is the social media, Reddit, the textual data, and then we have the price data, and we do an ingest and wrangling on both of these, and we get data frames that look like this. So here we see that there's a body, and there's a timestamp for when it was created, and there's a score. So score is basically just like the upvote on the comment or tweet. And then similarly, the Bitcoin price data looks like this, where you have a timestamp and you have a price associated with each timestamp. Next, we do NLP on these. We take two approaches to do natural language processing, like I mentioned before, the rule-based and the deep learning one. And then we get a data frame which looks like this. So there's a score, we had the score and the timestamp, and now we have a sentiment associated with it. it looks like this. So there's a negative value, there's a positive value, there is also a neutral value which we discard. And then in the next step, we combine these two data frames. So we have a data frame which is ready to be pre-processed and to run through an LSTM. So for the rule-based approach. So for the rule-based approach, we use Vader, which is an open source tool that is available via the NLTK library. And the NLTK library, the Vader was, it's a lexicon and rule-based approach, and it was created using a human-centered analysis, and they created a gold standard set of features by compiling the various human inputs given for a specific tweet or a tweet-like message. And it's available with NLTK, it's open source. The next approach we used was using the Stanford Core NLP to get labels on, to get the sentiment value calculated per tweet and comment. And the Stanford Core NLP provides a sentiment tree bank, and they have a model that is trained on the sentiment tree bank. The model is recursive neural tensor networks, which are like a tree-like neural network with a neural network at each node. And so we use this, okay. So our second approach, I'll describe the whole pipeline for this approach. I hope you can see the diagram. So we start from the bottom, where we see that we have the Reddit financial data. So we collect all the financial data, including like Bitcoin and stuff, and then we filter out the Bitcoin. So we do not consider Bitcoin-related tweets and comments. We just consider all other financial data. And then we label this data like for sentiments. So we get a labeled sentiment value per comment and tweet. And then we tokenize this data into sequence to pass it through an LSTM. So this LSTM will now just train on financial tweets and comments. And this LSTM consists of an embedding layer, which converts word to vectors. Then there's a dropout layer, there's an LSTM layer, and there's a fully connected layer. This now produces a model that is specialized, and it is specifically tuned to financial lingo. And we use this model to now predict the sentiment for Bitcoin-related tweets and comments. So now we have a sentiment associated with Bitcoin tweets and comments. We combine it, like I showed before, with the pricing data, and then we pass it through some pre-processing. So we normalize the data. Now normalization is important because we have a sentiment value which is in the range of 0 to 1, and we have a Bitcoin value that is like inflating or going really low. So normalization is important here. So we do normalization, and then we create a look back for LSTMs. So LSTMs have a look back window which considers the context of input that you need to keep per input that you give. So, and then we pass this through an LSTM which consists of 2 LSTM layers followed by dropout layers and two fully connected layers. And now we have a model that can predict and forecast the value of the Bitcoin price based on the window provided. Next, I'll pass it on to Joyesh to describe the workflow execution pipeline.
All right. So one of the key aspects for a successful deployment model is to reduce the friction between data scientists and deep learning research engineers. And help them execute the complete pipeline as frequently and seamlessly as possible. So this enables them to try out different layers, explore new features, try out even new data sources, as well as do hyperparameter tuning. To begin with, our approach was to pick 2 frameworks based on maturity, flexibility, and availability of tools around them. So what we ended up is, we ended up architecting the data processing piece using Spark and PySpark, and the deep learning piece was modeled using Keras and TensorFlow. So let me walk you through the from the left to right. So the data ingestion, data wrangling, pre-processing of the social media and the pricing data set was done using Spark SQL. Everybody, I would assume if you're coming to Spark Summit, you're familiar with the Spark SQL, PySpark APIs a little bit, so it came to us natural to use Spark SQL APIs. Then once we obtained the clean social data, we passed it on to the NLP component, which was initially implemented using NLTK Vader tool. We could easily import it onto PySpark and get the sentiments using Spark SQL. Once we have obtained both the sentiments and the pricing information, we join both the data frames using Spark SQL and normalize using Spark ML. Now that we have our features and data ready, the important point here is how do we get the data onto TensorFlow so that we can train the LSTM price forecasting pipeline in TensorFlow. So our team at Intel wrote a library called Spark TensorFlow Connector, which essentially does this job of importing and exporting TF records. TF records is a format which TensorFlow understands and implements. So Spark TensorFlow Connector essentially runs on top of Apache Spark and is able to load or store TensorFlow frames or records. It supports automatic schema inference and the record types, the example and sequence example record types are supported. So you can have a list of features or you can have a contextual temporal list of features which can be exported into the TF records. So that's how we could export the data out and then feed it into our Keras or TensorFlow pipeline and get the price forecast. So this was okay to begin with, and this is what I would imagine most of the beginners who are trying out this ecosystem would do. In the next iteration, when we ended up implementing the Core NLP based component, we further used this connector to take the social media data out once it has been pre-processed and ready for deep learning. Exported it out into some kind of TF records and then use the LSTM-based pipeline, which Shibani mentioned a couple of slides back. So we did all the processing and inference as well there to get the sentiment value using the updated financial model, and then bring it back onto Spark by importing it in using the Spark TensorFlow connector. And the rest of the pipeline is exactly the same. So it was a neat implementation, but it would go like it will become infeasible if we start adding more deep learning based components. So it also what we were seeing is the deep learning researchers, let's say the deep learning person who is doing deep learning is implementing in silo than the person who is doing data engineering. So we wanted something where they can share and execute the complete pipeline all the time and not just have to export, import these data frames. So the combined workflow which we ended up proposing is to use a library called BigDL. BigDL is a distributed deep learning library for Apache Spark. Apache Spark actually has like 3 libraries which run on TensorFlow. One is TensorFrames, TensorFlow on Spark, and BigDL. So BigDL can leverage almost all the goodness of Spark and work with this packages in the Spark ecosystem. It implements synchronous SGD and all reduce. All the layers you're familiar with, the convolution, recurrent layers are available. The important piece which made us use BigDL was the ability to reuse the Keras model which we had already developed in those pipelines and tested on small amount of data via export-import. It also provides the Keras style API. So if you have data scientists who are familiar with Keras, they can directly start using a BigDL because it has a set of APIs which models it around the Keras both sequential and functional style. And it has Python and Scala bindings, so you can pick and choose based on the language of your choice. So if you see, the overall framework is much more simplified now. We have the data ingestion and wrangling and pre-processing happening through Spark SQL. All the deep learning modules have been implemented using LSTM. One caveat is the Keras the version is a bit old. It supports 1.2.2. The current version of KRS is 1.6. So you might have some issues with the parameters. So we did have some of those issues, but we ended up trying to use some workarounds there. So we could import our KRS models and get the sentiments. Once we have the sentiments, we merge the data, normalize it using Spark ML, and use Spark SQL, and finally again use BigDL for the price forecasting model. So if you see, everything fits inside, works within the JVM. It can be distributed and run on Spark on Yarn, and you can get a robust execution framework. And you can essentially package everything as a single jar or a collection of jars and try it out, the model tuning, hyperparameter, or those kind of experiments many times as seamlessly and frequently as possible. All right.
So for the experiments that we performed, there are a few learnings I'd like to share. The first one is adding the transaction volume, that is the amount of Bitcoin traded, was an important feature, so it helped us improve our predictions. We have to normalize all the features to reduce any feature-based bias in the model. Different window lengths, we tried out different window lengths, and the one that we observed to be best was 22 hours for look back in LSTM, and further fine-tuning of the layers could improvise the predictions. So on the left, we see the deep learning based approach, and on the right is the Vader based approach. For the these are the results on 4 months of data. So my prognosis is that if you increase the amount of data set, you will get a wider difference between the results, between using deep learning and rule based sentiment prediction. And so there is a slight difference, and deep learning slightly outperforms the rule-based methods. On the right, we see how a graph looks over multiple epochs for the final LSTM that we apply for predicting the Bitcoin price. So, yeah.
All right. So further research in sentiment analysis is mostly happening around LSTM and recursive neural networks. The scientific community has subdivided the categories into document level, sentence level, and aspect level. So document level deals with documents which are themselves completely opinionated, like blogs or articles. Sentence level classification essentially does some kind of subjectivity classification to figure out if individual sentences are opinionated or not, and then do further analysis. Aspect level essentially deals with nuances of an entity or features. So a single entity might have multiple nuances or features, and each one of them might have different opinions. So that's more fine-grained essentially, and a little more complex. So if you see what in the document level essentially, the folks are using in production or in implementation today, mostly word embeddings, conversion into some kind of dense document form vectors, and finally some kind of LSTM. For cross-lingual or for little more temporal models, they are also proposing some kind of using some kind of attention mechanism, so you can extract those keywords which might be relevant in some language, and then use LSTM to create those features, and finally feed it to some kind of non-neural classifier like SVM to obtain a globally optimum classifier. I'm not going to go through a bunch of acronyms there. There's a nice survey paper which you can go over. One neat implementation was the character-to-sentence convolution neural network for sentence-level sentiment classification, which was proposed, which essentially uses some kind of convolution layers to look into short words within a Twitter text, and essentially kind of gives better accuracy and better compositional results. Some of the other research areas which people are discovering is emotional analysis, sarcasm detection, and multilingual, cross-lingual sentiment analysis models, again using LSTMs, bidirectional RNNs, and deep bidirectional RNNs. And finally, multimodal is also a research area where people are trying to combine textual, acoustic, and visual data. So again, using multiple LSTMs. So the key takeaways, what we got from this experiment and this proof of concept is Deep learning based NLP techniques are definitely comparable. So in the next time you are looking at a use case which you want to implement and which deals around natural language processing, definitely give deep learning a try, because it's become pretty easy to model your pipelines using Keras or Big DL or any of TensorFlow or any of the frameworks, and you can pick and choose the language of your choice. Iterated training and model tuning is also pretty easy on large data sets, so you don't have to focus only on small data anymore, because these frameworks are able to are mature, and as well as they are able to interoperate with each other and leverage each other. So so if you see here, Big Deal is able to use those APIs from Keras and use the best parts of each other and delegate the execution on Spark, so that all these tools are working with each other. Finally, model specialization and domain-based training should be given enough attention, because we understand that the model should generalize, but you should also focus on the domain or the problem case you are trying to handle. So in our case, we did with financial modeling. One of the examples which I want to highlight is the Stanford Dawn no-scope project, where they have shown that by using surrogate models, they could increment the object detection from 80 frames per second to 15,000 frames per second by just focusing on, let's say, the buses in Tokyo streets and not just the entire set of images it was trained on, like cats, dogs, and etc. So you should think of trying to use model specialization if you can. Finally, we would highlight some of the libraries which we used here. Spark TensorFlow Connector has been contributed to the TensorFlow ecosystem. And example notebooks are available on Databricks Cloud and Google Cloud platform. Both these libraries, Big DL and Spark TensorFlow Connector, leverage existing Spark clusters and add to deep learning functionalities. You can also look up examples and reference use cases on Big DL Analytics Zoo. So yeah, that's the end of our slide, and thank you.
Okay, I think there's a couple of minutes left for a few questions. If anybody has any, raise your hand. Yes.
Since both of the approaches were comparable, and if you were doing an application where you had to choose between the two, what are some advantages of the rule-based system where they're faster to train and easier to set up than the deep neural network? And that's basically the question.
So they are comparable, but my understanding is that since Vader, it's created using a general set of tweet messages, and even the tree bank model generalizes over all kinds of text data. We use a deep learning model that trains on data specific to the financial domain. So my understanding is that if trained on a large enough data set, it would perform much better. Yeah, that's it.
Hello, thank you so much for this. Like on the slide 19, you were comparing two different deep learning, I guess?
Yep.
And did you, I mean, are these like a out of sample root mean square levels?
Could you repeat that?
Are these out of sample values for the mean absolute error?
So these are values on the normalized data that we use. So these are mean absolute errors.
But for out of sample, right? You're not really using in sample values.
I'm not sure.
I mean, you're not really comparing them based on what you trained on, right? These are like for test data.
These are test data.
If so, did you compare these models to like a really simple ARIMA model, or are you making any progress with this deep learning when you compare to ARIMA model or any Marco?
So these are, so the model we trained on was on data from November to March for Bitcoin prices. So
I understand, but what I'm trying to understand is, are you making progress? Like when you compare this to a really simple autoregressive model?
We haven't compared it to traditional machine learning models or other models. We have just compared it to like, these two.
Okay, thank you very much.
Yeah.
Oh, okay, here we go. I was like, oh, no more questions, really?
Hi, when you were extracting your data from Twitter and Reddit, were you using public APIs, or did you?
So there's
the
Firehose for Twitter, but for Reddit, it's publicly available in zip format, so like tar formats divided by month. So we have Reddit comments available that have been downloaded by a user on Reddit. and it's available for download for free.
Okay, cool.
Yeah.
Thank you.
All right, guys, unfortunately we are out of time, but they will be available for you to mob outside. So once again, one more round of applause.